math teachers are evil. Story has it that the mathematician Gauss, you may have heard of him, one of you may have done a Facebook page about Gauss, that when he was in elementary school, his teacher had all of the students she could handle for that day and wanted to give them an assignment to keep them busy and out of her hair. So she thought, okay, this will do it, and assigned them to add all of the numbers from 1 to 1,000. That ought to keep them busy. Well, no sooner had she sat back down that young Gauss was there at her side with his slate to show her the answer. And she's thinking, no way, no way. But he had, in fact, given her the right answer for all of the numbers from 1 to 1,000. And young Gauss had gone at it this way. He had said, well, I'll write those numbers out, 1, 2, 3, 4, to 1,000. And then I'll do the same thing backwards. 1,999, 998, 9, and he probably didn't write on his slate much clearer than I write on my tablet, and all the way to 1. And then he said, let's add them up. 1,001, 1,001, 1,001, all the way to 1,001. Now then, so if you add each pair, 1,001, 999 plus 2, 998 plus 3, you get 1,001. All the way down to here where you get 1,001. How many thousands and ones do I have? So the total, the sum of that is 1,000 times 1,001, but I have 2 of them, twice as many as I need, so I divide by 2. And that's the sum of the numbers from 1 to 1,000. And that's easy to multiply. What's 1,000 times 1,001? Oh, don't be using your calculator. You can do that. How much? 1,001,000, right? 1000. You just take this number and put 3 zeros behind it, right? Okay. And divide by 2. So the answer is 500,500. That's all of the numbers from 1 to 1,000 added. Okay. If you recall, when we were doing our little series game, when you were giving me the expression, and whoever guessed the expression or deduced the expression, and you got all of the points, say from 17 down to 1, well, that's how I was doing that. 17 times 18 divided by 2 is all of the numbers from 17 down to 1. Okay? You will find that in your book, let's see, on page 595. It's expressed a little bit differently. It says S sub n is n over 2 a1 plus a sub n. Okay? Now again, this looks a little different than what I just said, but if we use our Gauss idea and that story, then this fills in as 1,000. That's my n. A sub 1 is 1. That's where I started. A sub n is 1,000. That's where I ended up. And now you can see how this works out just exactly the same as the story about Gauss. Now, whether that's true or not, I don't know. The first time I got that story was when I was in my calculus class in college, back when we still spoke Greek in math class. And Dr. Scanlon told that as he introduced some of the stuff that we were doing with sequences and series. Now, on the bell work, I had asked you a question, the third one, about the nth sum of an infinite sequence is a nth partial sum. Okay, this is exactly the same thing. This is the 1,000th partial sum of the infinite sequence of integers. Okay? You do not have to have sequences that are just integers, 1, 2, 3, in order to do this. We could do a sequence that was, counted by thousands or counted by twos and still do the same thing. You only have to know how many terms you want, that's the n, what the first term is, and what the nth term is in order to be able to use this. And it does have to be an arithmetic sequence. It has to be an arithmetic sequence in order for this to work.